Hi everyone, myself Satya, Department of Mathematics, SNS College of Technology, Coimbatore. In today's class, we are going to have the topic nature of the quadratic form. Okay, so before I enter into the topic, we should know the basic terminologies, okay, which is going to present in the problem. Okay, the first thing is nature of the quadratic form. Okay, so the first thing is rank. So rank is nothing but the number of non-zero eigenvalues. Okay, how many non-zero values we are having, okay, in a problem, that is called the rank. Okay, the next thing is index, which is nothing but the number of positive square terms. Okay, the number of positive square terms, which is nothing but the index. And the next thing is signature, so which is nothing but the difference between the positive and negative square terms. Okay, that is called the signature. And the nature is the nature of the quadratic form. We will have 5 cases, so we'll see one by one. Okay, the first thing is positive definite. So all the eigenvalues are positive, which is called positive definite. All the eigenvalues are negative, which is called negative definite. And positive semi-definite, which is nothing but all the eigenvalues are positive and at least one should be 0. 1 0, the remaining 2 should be a positive one, which is called positive semi-definite. And the next thing is all the eigenvalues are negative and at least one should be 0. Okay, so which is called negative semi-definite. The next thing is indefinite, which means we will have both case, positive value and negative eigenvalue. Combination of both, that is called indefinite. Okay. So now we are going to see a problem which is nothing but reduce the quadratic form q equal to 3x1 square plus 2x2 square plus 3x3 square minus 2x1 x2 minus 2x2 x3 formed by orthogonal transformation. And also we need to find the rank, index, signature and nature. Okay, so step 1 is we need to write the matrix form. They are given the quadratic form, we need to write the matrix form, then we are going to follow the same procedure. Okay, so the first thing is, yes, matrix form. Okay, so first you can take the square terms as the diagonal. Okay, so here the square terms are 3 2 3, so that is your diagonal. Okay, see in the matrix. Okay, yes, 3 2 3. Okay, the next thing is minus 2 x1 x2. Okay, which means x1 x2 coefficient is 2. You have to divide that value by 2. Okay, you can consider the first row as x1, second row as x2 and third row as x3. The similar way you can have the column as x1, x2, x3. Now you can take x1, x2 means which is first row, second element. Okay, that means that element should be minus 1. And x1, x2 and x2, x1 both are minus 1. Okay, okay, we don't have any difference between these two terms. Okay, the next thing is x2, x3, which means second row third element and third row second element both should be same, which is nothing but minus 1. You can divide minus 2 by 2, which is nothing but minus 1. Okay, and only we will have 5 terms in the quadratic form. Okay, but we need six terms. Okay, so one term is missing, which is nothing but, check it in the quadratic form, we'll have x1 x2 x2 x3. What are the next term? What should be the next term? Yes, x3 x1. That means first row third element and third row first element, it should be same, but we don't have any term in the quadratic form. That means that element should be 0. Okay, so this way I want to write the matrix form. Okay, the first thing is just write the square terms in the diagonal. Okay, go for the next term. Here the next term is x1 x2. Okay, x1 x2 and x2 x1 both are equal. Okay, for the remaining case you want to divide by 2. Square terms alone are to write the same value, but the remaining value are to divide by 2. That is the formula. Minus, okay, so 2 by 2 was minus 1. Okay, x1 x2 and x2 x1 both should be minus 1. Okay, the next thing is x2 x3. x2 x3 means x2 x3 and x3 x2 both should be same, which is minus 1. So one term is missing in the quadratic form, which is x3 x1 or x1 x3. That should be 0 because we don't have any element in the quadratic form. Okay, this way I want to write the matrix form. The next thing is, yes, step number 2. Step number 1 is we need to write the matrix form. That is over. Step number 2 is we need to write the characteristic equation. That is, we already know. We just solved so many problems in the previous classes. Okay, the same concept, which is lambda cube minus d1 lambda square plus d2 lambda minus d3 equal to 0. d1 is nothing but sum of the main diagonal elements. We just add the diagonals, so which is 8. And d2 is what? Yes, sum of the minus of the main diagonal elements, which is nothing but 19. Okay, and the third thing is determinant of A. So we know how to find the determinant of 3 cross 3 matrix, right? So which is nothing but 12. So we already know that concept. That's why I told the answer directly, right? Just replace d1, d2, d3 in the characteristic equation. So we are going to get the equation which is in the form lambda cube minus d lambda square plus 19 lambda minus 12 equal to 0. Okay, that is the equation we are getting. Okay, next thing is what? We need to find the eigenvalue. Either you can use the calculator or you can do it as manual. Okay, manually means to use synthetic division. So using synthetic division or to find the roots, which is 1, 3, 4. Okay, use the calculator or do it manually. Okay, so finally we are going to get the eigenvalues of 1, 3, 4. Okay, the next thing is what? We need to find the eigenvector. We already know the concept. A minus lambda into x equal to 0. Okay, so in the diagonal just add minus lambda. Then we are going to get the matrix which is in this form. Okay, check this form. Okay, and the first lambda value is what? 1. Just replace lambda as 1. So we are going to get the elements in the matrix which is of the form 2 minus 1 0 minus 1 1 minus 1 0 minus 1 2. Okay, into x1 x2 x3. That should be equal to 0 0 0. Okay, the next thing is just make it as x1 x2 x3 as the element we are going to write. Okay, just starting from, check the first 2 rows in the matrix. If it is equal or different, you can check it, right? Here it is different. So different means we know the concept, which is cross multiplication method. For that we have to start from the element of x2, coefficient of x2, which is nothing but for first 2 rows. Okay, x2 means the middle part. Okay, which is minus 1 1. The next x3 coefficient, which is 0 minus 1. The next thing is 2 minus 1, and the last thing is minus 1 1. This is, we already know the concept, the same concept. Okay, next x1 by, just make it as cross multiplication, 1 minus 0, and x2 by 0 plus 2, and x3 by 2 minus 1. Okay, finally we are going to get the element 1 2 1, which is our first eigenvector. Okay, the next thing is we need to find the eigenvector corresponding to lambda equal to 3. The same procedure ought to follow. Okay, this is the matrix we are getting, right? We got this matrix. In this case, just replace lambda as 3. Okay, first element 0, second element, middle of the element is minus 1, and the last it's also 0. Where it reflects, yes, which is only in the diagonal one. The remaining elements are as it is. Okay, we are going to get the matrix which is of this form. Okay, now we check the first 2 rows, 0 minus 1 0 minus 1 minus 1 minus 1. So those two matrices are, those 2 rows are different, which means we are going to use cross multiplication method. So x1 and x2 x3, we are going to start with the coefficient of x2 minus 1 minus 1 0 minus 1 0 minus 1 minus 1 minus 1. Next one by, make it as cross multiplication, so 1 minus 0, and x2 by 0 minus 0, which is 0, x3 by 0 minus 1. Okay, finally we are going to get the eigenvector which is of the form 1 0 minus 1. Okay.